Oh my God, there are so many reactions in chemistry. How am I going to learn all these chemical reactions? Don't worry. In this video, we are going to visualize the chemical reactions in an interesting way using these simple blocks. Since there are so many reactions, we are going to divide them into 5 important types. I'm also going to show you how to predict the chemical reactions based on these types. So you won't have to memorize all the reactions. And as usual, we'll finish off with our top 3 questions on this topic. Chemical reactions can be divided into these 5 important types. In this video, we're going to look at each of these types and their examples. Now, if you're not sure how to write chemical equations and how to balance them, then I would suggest you to watch that video before continuing here. So friends, are you ready? Let's go to our chemistry lab. First, let's start with combination reactions. In combination reactions, 2 or more substances combine to form one single substance. Let's visualize it with our blocks here. Let's say we have 2 substances, A and B, and they combine to form one product, AB. This is a combination reaction. In combination reactions, you have 2 or more reactants, but only one product. Now let's look at some examples. Let's say this pink block here is hydrogen, and this block is oxygen. Now when they combine, we get water. This is a word equation since it's written in words. Now let's write it as a chemical equation. So we have H2 plus O2 giving us H2O. Note that the product is not a simple join of the formula of the reactants. So it's not H2O2, it's H2O because the elements combine according to their valency. Now here the equation is unbalanced. So let's go ahead and balance the equation. Another example is magnesium and oxygen combine to form magnesium oxide. So we have Mg plus O2 giving us MgO. Now let's balance the equation and we get 2Mg plus O2 gives us 2MgO. In these simple examples, the reactants were elements and the product was a compound. But the reactants can also be compounds. Let's take an example. Let's say we have carbon monoxide and oxygen. Carbon monoxide is a compound and oxygen is an element. And when they combine together, we get carbon dioxide. Now why don't you try predicting the next reaction? Hint, it's a combination reaction. If you combine sodium and chlorine, what are you going to get here? Sodium and chlorine combine to form the compound sodium chloride. But the correct formula is NaCl. It's not a simple joining of Na and Cl2 because the elements combine according to their valency. And valency of sodium and chlorine is both 1. So we get the formula NaCl. Let's put combination reaction on our concept board. The key point is only one product. Next, let's look at decomposition reactions. Decomposition reactions are the opposite of combination reactions. In decomposition, one compound breaks down into 2 or more simpler substances. So once again, let's visualize it using our blocks here. Let's say we have a substance AB. It decomposes or breaks down into 2 substances, A and B. This is a decomposition reaction. In decomposition reactions, you have 2 or more products. But remember, only one reactant. Now let's take a look at some examples. Let's say we have water here. And when you pass electric current, it breaks down into hydrogen and oxygen. This is also known as electrolysis since electric current is used to decompose the compound. Remember, this equation is exactly opposite of what we did in combination, where hydrogen and oxygen combine to form water. Another example of decomposition is when you heat calcium carbonate, it decomposes. Calcium carbonate decomposes to produce calcium oxide and carbon dioxide. This is called thermal decomposition since heat causes the decomposition. Now let's try predicting the next reaction. Do you know what happens when silver chloride is exposed to sunlight? That's right, silver chloride decomposes into silver and chlorine. Do you know where this reaction is used, or rather was used? In black and white photography, where the film or the photographic plate contained silver chloride and it decomposed when it was exposed to sunlight to give us the black and white image. Of course, now in the digital world, everything's digital and we are using SD cards. Now let's consider another example, digestion of food. So when you eat food, what happens in the digestion process? Is it a combination reaction or a decomposition reaction? What do you think? That's right. The correct answer is decomposition reaction. Our digestive system breaks down the complex food substances into simpler substances. For example, carbohydrates are broken into simpler sugars such as glucose. Proteins decompose to form amino acids. So digestion is a decomposition reaction. Let's pin decomposition reaction on our concept board. Remember the key point? Only one reactant. Next, let's look at displacement reactions. In displacement, a more active element displaces or takes the place of a less active element in a compound. These are also called single displacement reactions. Let's understand these with the help of our blocks here. So let's say here we have element A and compound BC. Now A is more reactive than B. So it's going to displace or push off B and combine with C. So now B is alone here. So we have AC plus B. This is a displacement reaction. As we saw here, the more active element A is displacing the less active element B. Now how do we know which element is more reactive than the other? In chemistry, we have a reactivity series. Here's what it looks like for metals. Metals on the top are more reactive, and as you move down, the reactivity decreases. For example, if you look here, sodium is more reactive than iron. Hydrogen is also in this list even though it's a non-metal because it's electropositive in nature and can be displaced by metals. There is also a reactivity series for non-metals, the halogens. This is what the simple reactivity series for important halogens looks like. Fluorine is the most reactive and iodine is the least reactive. Now let's look at some examples of displacement reactions. Let's say we have zinc and hydrochloric acid here. Now, since zinc is more reactive than hydrogen, according to the reactivity series, it can displace it. So we get zinc chloride and hydrogen. This is our displacement reaction. Another example is potassium iodide and chlorine. This example involves non-metals. Chlorine is more reactive than iodine. So chlorine can displace iodine from potassium iodide and we get potassium chloride and iodine. So here we had displacement of non-metals. Now let's try predicting the next reaction. What happens when an iron nail is placed in copper sulfate solution? First, let's write down the reactants. So here we have iron and copper sulfate. Now we know that iron is more reactive than copper. So iron is going to displace copper from copper sulfate. And what are we going to get here in the displacement reaction? That's right, copper and iron sulfate. We can even predict the observations based on this reaction. So we know that copper sulfate is blue in color and iron sulfate is green in color. So the color of the solution is going to change from blue to green. And since you have copper being deposited here, you're going to see a reddish brown deposit on the iron nail. Now what do you think will happen if a copper piece is placed in iron sulfate solution? What are the products now? That's right, there's going to be no reaction because copper is below iron in the reactivity series. So copper cannot displace iron. Let's put displacement reaction on our concept board. Remember the key point? A more active element is displacing a lesser active element. Previously, we did displacement or single displacement reactions. Now let's take a look at double displacement reactions. In a double displacement reaction, two compounds react with each other and exchange their ions to form two new compounds. So let's go ahead and try it with our blocks here. Let's say we have two compounds, AB and CD. Now there is an exchange of ions and we get two new compounds, CB and AD. This is a double displacement reaction. Now you may be thinking, do we need to use the reactivity series again for double displacement reactions? The answer is no. Reactivity series is only used for single displacement reactions. Because if you look at double displacement, we can't say that A is displacing C or C is displacing A. It's simply an exchange of the ions. So remember, reactivity series is only used for single displacement reactions. Now let's take a look at some examples of double displacement. Let's say we have silver nitrate here and sodium chloride. To analyze the reaction, let me switch these blocks so that the reactants and products match. First, split the reactants into their ions. So we have silver ion and nitrate ion and sodium ion and chloride ion. Now you can exchange the cations or the anions. So let's exchange the cations here. If we exchange the cations, positive ions, silver and sodium, we get sodium nitrate and silver chloride. So this is our double displacement. Remember, exchange the cations or the anions. Don't exchange both the cations and anions. Otherwise, you'll get back the original reactants. Another example is sodium hydroxide and hydrochloric acid. Again, let's go ahead and exchange the cations. We will get sodium chloride on the product side. And when OH minus and H plus ions combine, we get water. Do you know another name for this reaction? The correct answer is neutralization, because sodium hydroxide is neutralizing hydrochloric acid to produce water and salt. Now let's try predicting our next reaction. What happens if we mix lead nitrate and potassium iodide? First, let's write down the formulae of the reactants. So we have PbNO3 whole 2 and Ki. Next, we are going to cut the reactants into their respective ions. Now let's exchange the lead and potassium ion. So what are we going to get? That's right, we'll get potassium nitrate and lead iodide. Now lead iodide is insoluble in water, so it forms a precipitate, and this is also called a precipitation reaction. And since it's yellow in color, we are going to get a yellow precipitate here. Let's put double displacement reaction on our concept board. The key point here is exchange of ions. Now let's look at the fifth and final type of reaction, redox reactions. Redox stands for reduction and oxidation. In these reactions, one substance is being reduced and the other is being oxidized. First, let's understand the meaning of these terms, oxidation and reduction. In simple terms, oxidation means addition of oxygen and reduction means addition of hydrogen. But there are other ways of defining oxidation and reduction. So let's go ahead and make a table of oxidation versus reduction. We just discussed the first difference. Oxidation is addition of oxygen and reduction is defined as addition of hydrogen. Oxidation can also be defined as removal of hydrogen and reduction is removal of oxygen. Now, oxidation need not be only addition of oxygen. We can expand the definition to addition of any non-metal or electronegative element. Similarly, reduction can be addition of a metal or electropositive element. Now we can define oxidation as removal of a metal or electropositive element, and similarly reduction is removal of a non-metal or electronegative element. Oxidation can also be defined as loss of electrons and reduction is gain of electrons. You can remember the last difference with the help of this simple mnemonic, oil rig. Oil stands for oxidation is loss of electrons and rig stands for reduction is gain of electrons. Let's look at some examples of redox reactions. Let's say we have copper oxide and hydrogen here, and when they react we get copper and water. Now if you look carefully, this is a displacement reaction because hydrogen is displacing copper from the compound copper oxide. Now let's take a look from the redox point of view. So if you look here, copper oxide is losing oxygen and becoming copper. So copper oxide is getting reduced here. And hydrogen is gaining oxygen and becoming water. So hydrogen is getting oxidized in this reaction. And remember, always the reactants get oxidized or reduced, not the products. In this reaction, hydrogen is helping copper oxide to get reduced to copper. So hydrogen is the reducing agent. And copper oxide is helping hydrogen get oxidized to water. So copper oxide is acting as the oxidizing agent. So remember, the substance that gets oxidized is the reducing agent and the substance that gets reduced is the oxidizing agent. Now let's take a look at some more examples of redox reactions. Let's say here we have copper and oxygen, and when they react we get copper oxide. Now who do you think is being oxidized and reduced here? Let's take a look. So if you look at copper, copper is changing to copper oxide. So oxygen is being added to copper. So copper is being oxidized here. Now what about oxygen? Since a metal is being added to it, oxygen is being reduced. So oxygen is our oxidizing agent and copper is the reducing agent in this redox reaction. Let's look at another example. Hydrogen sulfide and chlorine react to give hydrogen chloride and sulfur. Now who do you think is getting oxidized and reduced in this reaction? Remember, the answer to this question is only the reactants, not the products. So let's take a look at the reactants. So if we see hydrogen sulfide, it's changing to sulfur. Since hydrogen sulfide is losing hydrogen, so that's correct, it's getting oxidized. And if you look at chlorine, hydrogen is being added to it and it's becoming hydrogen chloride. So chlorine is being reduced here. Let's pin redox reaction on our concept board. Remember the key point, reduction and oxidation are both taking place. Friends, I hope the 5 important types of reactions are crystal clear to you now. So next time you see a chemical reaction, I would encourage you to fit it into one of these types, and that will help you predict the reaction. So you won't have to memorize all the reactions. And now are you ready for the top 3 questions on this topic? Try solving these questions and let me know your answers and doubts by putting it in the comments below. I promise to reply to all your comments as soon as possible. So I'm going to disappear and you pause the video here and give these questions a shot.